first speaker for today is Johan Philip. And Johan is a 10-year-old math and science enthusiast. He lives in Tiruvalla, Kerala. Apart from mathematics, he loves coding and he's a great swimmer. He has also represented his school team for swimming. He plays the keyboard and he also enjoys solving puzzles. And when he's free, he loves to explore numbers, tries to find patterns in numbers, and he explores more and more patterns in numbers. And apart from all this, he is passionate about astronomy, and he is hopeful that one day he'll visit Mars and explore the planet. And I'm sure that day is not very far away. Johan, we are very happy to have you as the first speaker of this second series. And over to you, Johan.
Okay. Good evening, Vinay sir, guests, and my dear friends. Today I am here to do my presentation for Inspiring Talks by Inspired Minds on black holes. Black holes. This is a news clipping from the Times of India newspaper. On the 30th of June 2021, scientists detected gravitational waves from a neutron star and a black hole collision. Indian researchers were also a part of this finding. Have you ever wondered what exactly is a black hole? That's what we're going to find out in this presentation. What is a black hole? A black hole is a place in space where gravity pulls so much that not even light can get out. Anything that goes too close to a black hole, a star, a planet, or maybe even a spacecraft, will be stretched and compressed like putty in a theoretical process aptly known as spaghettification. Now let us explore the characteristics of a black hole. A black hole's gravity is very strong because a lot of matter has been squeezed into a very tiny place in space. In other words, a black hole has a very high density. They are also invisible because light around a black hole is absorbed by the black hole, and so none of the light reaches our eyes and we can't see it. This is an artist's drawing of a black hole named Cygnus X1, the first black hole ever discovered. Elements of a black hole. An accretion disk is a swirling mass of matter destined to spiral into the black hole or be ejected into space. However, not all black holes have these. Relativistic jets are jets of matter and radiation that extend out to hundreds of thousands of light years. But even these are not found commonly on black holes. But one thing that is found on every black hole is the event horizon, the gravitational boundary beyond which neither light nor matter can escape. How big are these black holes? Black holes can be big or small. Scientists think that the smallest black holes are the size of just one atom, but these have the mass of a large mountain. Stellar mass black holes have masses of around 20 suns. That is, stellar mass black holes have masses of 20 suns put together. On the other hand, supermassive black holes have masses of from 1 million suns, which is a lot. Sagittarius A star is the supermassive black hole at the center of our galaxy. It has the mass of 4 million suns and would fit inside a very large ball that can hold many millions of Earths. Now let us see what are the types of black holes. There are 4 types of black holes. The first one is the miniature black hole. The second, stellar mass black holes, intermediate mass black holes, and finally, supermassive black holes. Stellar mass black holes. They are formed when a single massive star runs out of fuel. The smallest stellar mass black holes have masses of more than 3 times the mass of our sun. They are spread throughout the Milky Way galaxies and other galaxies in our universe. An example is Cygnus X1, the first black hole ever discovered. This is an X-ray image of Cygnus X1 taken by NASA's Chandra X-ray Observatory. Supermassive black holes. Supermassive black holes are formed when many enormous black holes combine into one enormous black hole, superenormous. They have masses of from millions to billions of times the mass of our sun. They are found at the centers of galaxies. An example is M87 star in the heart of the Messier 87 galaxy. The first optical image of a black hole taken by the Event Horizon Telescope was one of M87 star. Intermediate mass black holes. They are thought to form when multiple stellar mass black holes undergo a series of mergers with one another. But that is not the only hypothesis for the formation of intermediate mass black holes. There are two others. One is the runaway collision of stars in a dense star clusters, with the product collapsing into an intermediate mass black hole. The other one is that intermediate mass black holes are primordial black holes. Primordial black holes are black holes formed soon after the Big Bang. Intermediate mass black holes have masses of 100 to more than 10,000 solar masses. One solar mass has the same mass as our sun. On the 21st of May 2019, the National Science Foundation's Laser Interferometer Gravitational Wave Observatory, or LIGO for short, detected gravitational waves from the merger of two black holes. The resulting black hole, the gravitational wave event dubbed GW190521, resulted in a black hole weighing 142 solar masses, thereby it being classified as an intermediate mass black hole. And finally, the last kind of black hole. This kind of black hole is purely theoretical, the miniature black hole. They are thought to have formed from dense spots in the early universe soon after the Big Bang, then quickly evaporated. In other words, they are also primordial black holes. They have a minimum mass of about 10⁻⁸ kilograms. Since these are purely theoretical, we are yet to find an example of one. Now let us see how black holes are formed when black holes are formed. Scientists think that the smallest black holes formed when the universe began, and that supermassive black holes were formed at the same time as the galaxy they are in. A star uses hydrogen as nuclear fuel in a process known as nuclear fusion. In nuclear fusion, two hydrogen atoms combine into one helium atom. Now this process releases a lot of energy, which pushes outward on the star. At the same time, gravity created by the mass of the star is trying to pull the star inward. Most of the time, these forces balance. But at the end of a star's life, when it runs out of hydrogen, it can no longer generate that outward push. So gravity wins and the star collapses into a black hole. If black holes are black, how do scientists know they're there? Earlier, we answered why we can't see a black hole in the first place. Because light around a black hole is sucked into it, and so none of that light reaches our eyes. So how do scientists see a black hole? One way is to use satellites and telescopes in space to detect high energy light created when a star and a black hole are together. Another way is to study stars that are flying around or orbiting a seemingly empty place in space. But that place is probably not empty. It could be the place where the black hole resides. All this talk about black holes could have raised the question in your heads. Could a black hole destroy Earth? Fortunately, the answer is no, because no black hole is close enough for Earth for that to happen. But what would happen if there was a black hole with the same mass as the sun in the sun's position? Nothing would happen, because if that black hole had the same mass as the sun, it would also have the same gravitational force of the sun. And so the planets would keep on orbiting their black hole as they do orbit the sun today. But will the sun ever turn into a black hole? Thankfully, no, because the sun is not a big enough star to turn into a black hole. We just discussed the question of if a black hole could destroy Earth. But can a black hole be destroyed? Yes, due to something known as Hawking radiation. Hawking radiation works because empty space or the vacuum is not really empty. It's actually a sea of particles popping in and out of existence. If such a pair of particles is formed near the black hole, there is a chance that one of them will be pulled into it. In this scenario, the other black hole escapes to space. The energy from the escaping comes from the black hole, and so the black hole slowly loses energy and mass by this process. But it would take more than the entire age of the universe for most black holes we know about to significantly evaporate. Black holes, even the ones just a few times the mass of the sun, will be around for a really, really long time. Can someone identify the person in the picture, in this slide?
The answers can be put on chat.
Yes,
answers are
it's
coming
Stephen
to me.
Hawking. It's Stephen Hawking. Stephen Hawking first theorized Hawking radiation. Okay. X-ray binaries. A spectacular set of rings has been found around a black hole in a binary system called V4O4 Cygni, located about 7,800 light years away from Earth. A light year is the distance light takes 1 year to travel. Or in other words, light travels a light year in 1 year. This black hole is actively pulling material away from a companion star. The star has a mass of about half the mass of the sun. The entire thing glows in X-rays. So these kinds of binary systems are known as X-ray binaries. Let me show you something interesting. Okay, you can see the constellations Virgo and Leo. Now you can see this beautiful dark background against which tiny pinpoints of light stand out. Now we are now zooming into the elliptical galaxy Messier 87. You can see it looks like a little egg, little white egg. Now as we are zooming in, you can see this red gas cloud. At the very heart of all this, we will find M87 star, the first black hole ever to be taken an optical picture of. The Event Horizon Telescope took an optical image of this the Event Horizon Telescope took an optical image of this black hole. The first ever optical image. These are my references. The Theory of Everything is a book written by Stephen Hawking that answers many questions about the universe and black holes. Thank you.
Thank you so much, Johan, for that wonderful presentation. It was really, really very inspiring, and I almost got a free tour into space. I'm sure others also would have felt that way. So this is to the audience. If you have any questions that you would like to ask Johan, you can do a raise hand and we can unmute you and you can ask your question directly. All right, there are hands raised immediately. So I'll start with Smayan.
Hello, can you hear me?
Yeah.
Yeah, so my question is, how do you take the image of the optical image of the black hole, the first black hole that was created, that we took an image of?
Yeah, I actually expected this picture because this question because everyone would be thinking, if light cannot escape from a black hole, how can you take the picture? Yeah, so when matter is falling into the black hole, it's accelerated into very high speeds. Now, when it's accelerated into very high speeds, all this gas starts glowing. So if the light doesn't touch the event horizon, that gravitational boundary, it can escape. the escape velocity is low enough for it to escape, and so we can take the image of this.
Okay. So essentially some light escapes and it highlights the black hole.
Exactly.
Okay. Yeah, thank you.
Adrit.
This is a question related to Smayan's question, I think. Like, if how would the satellites know how to aim at before the event horizon? I mean, it being more than several light years away. It's not very easy to take a picture of it like that.
Yeah, so they don't use satellites in space to take optical images of black hole. They used lots of telescopes on the ground. The Event Horizon Telescope is virtually a telescope the size of the Earth, because you have radio telescopes situated all around the Earth. So these you take into account whether
Okay. So they put the radio waves into one specific spot and they concentrated that to take a picture.
Yeah, something like that. No, you use optical telescopes as well to try to find this light. You see if the weather is good and if the Earth is oriented in the correct position, and so you can try getting optical light. That is light that you can see with your eyes from black holes.
Wait. Okay, so now they had to wait several months for the Earth to be positioned in a specific way.
Yeah, sometimes. I mean, when they were trying to take the first few images, you had to align it properly, right? Only if you align it properly can you take a good image.
Okay.
It's like a camera. You don't put it in the correct way, you won't take the image you want. It's the same thing. It's like a cosmic camera.
I got that.
Okay, moving on ahead to the next person, Siddharth.
Johan, can you explain again what is Hawking radiation?
Okay, so you heard of the vacuum, right? Empty space.
Yeah, I've heard of vacuum.
Yeah, so sometimes virtual particles. So there are these little particles that just pop in and out of existence. So they always come in pairs, okay? So if one of these pairs is formed near the black hole, one of them could be sucked into it, the black hole. The other one will escape into space. I mean, escaping into space certainly takes some amount of energy. The black hole provides energy for that. And so in the formula E equals mc squared, if you lose a little bit of energy, you lose a little tiny bit of mass. So it's like that. You lose enough energy and you lose enough mass for the black hole to like shrink and disappear.
Oh, okay, I get it. Thanks.
Okay.
Vagisan.
Okay, so my question is like, how is it like possible to like see how is the black hole discovered?
Sometimes these kinds of black holes called quasars. No. Okay, so these kinds of black holes, they don't. It's not. I already covered that. So one way is by measuring the high energy light, like gamma rays and X rays created when a star and a black hole are close together, right? Okay. Another way is to see stars that are orbiting an empty place that could contain a black hole.
Okay, like I'm telling, like who, how was it discovered? Like who discovered it? That.
Oh, that kind of information. You mean Cygnus X1, the first black hole ever discovered?
I'm telling like who first discovered a black hole and who discovered like and came up with the theory of a black hole.
Oh, that I'm not really sure. It actually goes a bit of a long way ago. It came they thought of it long time ago. So
okay, got it.
I'll have to get more information on that.
Okay, Shabirish and Radhika.
Yeah, thank you, Johan, for the very informative talk. So it is not a question, it's just a additional info. So you may be knowing like LIGO, you are mentioning about LIGO, laser interferometer for gravitational wave observation.
Yes.
So there are four such facilities already in operational all over the world. Two in LIGO Livingston and LIGO Hanford, one LIGO Virgo in Italy, and Gagra in Japan. And the fifth one, we are fortunate that we are going to have it in India. It is very close to or between Pune and Hyderabad in a place called Hingoli. And the researchers are working on that, and it is expected to be operational by 2024. Just since you are mentioning on LIGO, I just thought I'll add.
Yeah, okay. Thanks for the info.
Thank you.
All right. So it looks like there are no further questions. So I'll just end this with one question that I have to you, Johan. So who is the scientist that you admire the most? Who's your hero, and why?
In what topic? Because I have a lot of scientist admirers in different topics.
Okay, so if it's a general thing, who's your favorite? I mean, anyone who you want to name?
Stephen Hawking.
Why?
Because he figured out black holes, he figured out Hawking radiation, he figured out lots of stuff, like your universe had to be spherical and stuff. He thought of the spherical, he thought of how the universe would end and how the universe, I mean, he was one of the supporters of the Big Bang theory. So how can I not resist having Stephen Hawking as my admirer?
Good one.
Yeah.
And what's your plan further down? How are you planning to continue your study into black holes, or is there any place that you are stuck with in lack of resources, or you would be looking forward to getting some assistance or help from people? I'm asking this question so that amongst the viewers, if they have any suggestions, if they have anybody whom they can connect you to, you can you can get connected to such people. So anything on that front?
Not really.
All right. Okay. So thank you, Johan, once again. Wonderful presentation and taking us into space and bringing us back to this virtual floor.